look at how much more it is moving. Not only that, but the shape that it's moving at has changed. So looking at the spacecraft here, we have IMAP on top of a payload adapter and a rideshare ring, which has SWIFO opposed to Carruthers. And all three of these spacecraft are forming one unique payload stack, one unique system. Throughout our coupled loads analyses, we derived the launch environment that these would experience during flight. And much like I shook this rocket model, we also shook those spacecraft during vibration testing to make sure that they are rated to and can survive the vibrations that these spacecraft will see during launch. So in the end, we found that through analysis and testing, these three spacecraft are ready to go and they are good for launch.
Thank you so much, Natalie. Appreciate the time, and thanks for explaining it.
Absolutely.
Now, this isn't the first time NASA and SpaceX are working together to send great science into orbit. For more on that, let's head back to Amanda and Hawthorne.
Thanks, Megan. Since 2016, NASA's Launch Services Program has partnered with SpaceX to fly some of the agency's most important science missions, spanning everything from Earth climate monitoring to astrophysics and planetary defense. In 2016, we launched our first LSP mission, Jason-3, which was a payload to measure global sea level rise. That success paved the way for TESS in 2018, a mission that transformed our search for planets by scanning nearly the entire sky for new worlds. In 2020, Sentinel-6 Michael Freilich carried a radar altimetry reference mission to extend the legacy of sea surface height measurements. This is critical to understanding climate change. Altimetry is the study of height, or measuring altitude, things that go up. And in this context, Sentinel-6 carries a suite of instruments which provide high-accuracy altimetry data monitoring for sea surface height, significant wave height, and wind speed, as well as monitoring inland water levels and ice characteristics. Then in 2021, LSP entrusted Falcon 9 with DART, the first ever test of planetary defense. And that went on to prove that humanity could intentionally change the orbit of an asteroid moonlet. That same year, IXPE opened a brand new window to the universe by measuring the polarization of X-rays from black holes and neutron stars. The collaboration continued with SWOT in 2022, which is now delivering detailed global maps of rivers, lakes, and ocean currents. And then with Psyche in 2023, a Discovery-class mission to explore the metal-rich asteroid 16 Psyche. This will reveal how planets may have formed, and that launched on Falcon Heavy. PACE, GOES-U, and Europa Clipper all launched in 2024. Europa Clipper, NASA's flagship mission to Jupiter's moon Europa, was sent to search for signs of life beneath its icy shell. PACE and GOES-U are working to advance our understanding of plankton, aerosols, clouds, and ecosystems that regulate Earth's climate to strengthen severe storm and space weather monitoring, respectively. In March of this year, Falcon 9 launched the SPHERE-X mission to survey the entire sky with infrared light. That launched alongside PUNCH, which will study the sun's outer atmosphere. Just in July, tracers delivered twin satellites to investigate magnetic reconnection, the fundamental driver of space weather. That brings us to today, where IMAP will head out to chart the boundary where solar wind meets interstellar space. And later this year, Sentinel-6B will take the next step in precision ocean altimetry, extending the global sea level record, which is critical for tracking climate change. Now, looking ahead, the Nancy Grace Roman Telescope, an observatory designed to study dark energy and dark matter, search for exoplanets and image them, and more, will tackle some of the biggest questions in science while generating data to help protect the Earth. In less than a decade, SpaceX has built a proven track record with NASA's Launch Services Program, establishing Falcon as a dependable launch platform for some of the most ambitious and groundbreaking science of our time. And that brings us back to today's IMAP mission, where we are just under an hour from the beginning of spacecraft deployment. So let's check back in with Megan.
Yeah, it's time for more questions from social media. The first one is, what new technology is being used on these missions?
That's a great question. So a lot of these missions have developed new technology in terms of the cameras that they use, in terms that like the camera in Carruthers. Although Dr. George Carruthers built an amazing thing. There's been a couple of advancements since 1972.
I would hope so, yes.
Yes, I hope so. So there's been some updates there. All of the detectors have been updated, and all of the new instruments on IMAP are improvements upon the older versions of these. And for SWIFO L1, since it's operational, it is an upgraded version of former instruments, but it's not too far off, because again, we want to make sure that they're the same, we have a consistency in those measurements and that they're very similar to past measurements.
Yeah, absolutely. That makes sense. You want to make sure you're still, even though there's advancements like comparing apples to apples,
exactly.
essentially.
Yeah, you want to keep that the same.
Got it. Same fruit. Now, this next question is Chili Maple. How long will mapping the heliosphere take, and when will the research contribute to safeguarding Earth?
Oh, that's a great question.
Yeah.
So to actually map the heliosphere, it's going to take a while, because the spacecraft takes turns and basically gets little bits of the sky every time it turns. And to make that full rotation as it rotates with the Earth, it takes about a full year to get one of those maps. So that's great because we have a 2-year mission. However, it also has the iAlert system on IMAP, which will be able to feed us data basically instantaneously or within 30 minutes. Get data about space weather that will be beamed back. So that long-term space weather, that galactic space weather, will take about that year, but that instantaneous will get started in 6 months once it's fully commissioned.
Wow, very impressive. Thank you so much, Kelly. Yeah. And as Kelly said, really, really great questions. Yeah, keep them coming. You still have time. Again, using that hashtag AskNASA on our social media platforms. Now, all 3 spacecrafts, IMAPs, Carruthers, and SWIFO L1, will monitor space weather from Lagrange Point 1.